Alrighty guys, for you just joining us, we just typed in all those notes. Pause them, understand them, and now we continue. Okay, so %20s as part of a printf means make it fill 20 spaces. Right justified. If we want to left justify it, what do we do? Put a hyphen, yep. If we want to specify both or a number of decimal places in a floating point, how do we do that?
Put a decimal.
A dot, right. Printf %dot to f comma d. Two places after the decimal point. We can go nuts. String as many as we possibly can in them. We want it to be right justified. We want commas throughout the number. We want it to be 20 wide, and we want 4 decimal places. I really can't think of any more than that than we could add. But the comma means put style commas in it. That was the only new thing. If you want to print it out in hexadecimal form, an integer, I believe you can use %x. If you want to print it out in exponential form, %e. I think that about covers it. Oh, and lastly, if you're going to compare two strings, S1 is equal to Joe, S2 is equal to Bob, how do we compare this? Do we do if S1 equal S2? You can probably tell by the way I phrase that question that the answer would be no. How do you compare those two values in this language? Because it's different than other languages. Dot equals. If S1 dot equals S2. Or if S1 dot equals ignore case S2. So I think we wrote a program. No, that was the other class, I believe. Never mind. But if you ask for a character, you know, A to append to the file, O to open it, C to close it, then you might use ignore case in order to let them type in an upper or lowercase letter. Okay, onward and upward. We did some printing of tables, and we did that without discussing arrays, I believe. Have we gone into arrays yet?
We touched them, but...
Touched them? Okay, we'll touch them further. Okay. Arrays are in Chapter 9, so we're jumping from Chapter 5 to Chapter 9 because we're cool. Alrighty, y'all are typing way more than I am. What are y'all working on?
Bill's writing notes.
Okay, cool. I mean, I'm not going to yell at you. I'm curious. Alrighty, so what is an array? An array is a series of elements of the same type. It's a series of data values. You know, a variable holds one piece of data. An array can hold a lot of pieces of data. Now, then we get into some subtleties. What an array really is it's a pointer to memory. So it still is just one thing, but it's pointing to memory that has multiple elements in it. But that's kind of shading the point. So somewhere, if we had an array of integers and we said that each array is, each int is 4 bytes long, and then we copy Jenny's phone number into it, 8675309. And behind the scenes, this is memory address 1000. That's memory address, well, the size of an int is 4. That's memory address 1008, 1012. If we were awesome, we'd express these in hexadecimal, but yeah. Okay, so here we go. This is our phone number array, num. Let's declare it. Int num is equal to 8675309. That's an example of using an initializer list. Or initializing list. Or an initializer, however we want to say it. So if an int is 4 bytes, and if we pretend the array starts at byte 1000, then behind the scenes, if we do this, num0, it retrieves the number from memory address byte 1000. Gets 4 bytes from there. If we say num1, then it retrieves them from byte. You can see what it did. If that's 1000, that's 1004, 1008, 1000, whatever. So the formula it uses is the starting address plus the index times the size of the data element. Now in Java, we don't really worry too much about that. We really don't worry about it at all. In Java, you don't get the index, the address of things. That's a C and a C++ style. In Java, we don't really care very much about the size of elements. But that's how it's working behind the screens, behind the scenes. And you won't only be Java programmers all your life. You'll be other programmers as well. So that's why I mentioned that. So how long is this array? Well, say we wanted to find out. We could print that out. Print num dot length. That'll return the length of the array. Notice that that's different than the string dot length. To get the length of a string, you have to put the parentheses. To get the length of an array, you leave the parentheses off. Just a little bit of a quirk, but an array has properties, but an array does not have functions, methods attached to it. And so the length is a property of the array. I say that, we could prove that or disprove that, and I'm going to get NetBeans going. Why do you need to know the length of the array? So you can't go past the end. That's element 0, that's element 1, just like on our string, 2, 3, 4, 5, 6. That means that since it's a phone number, it's got 7 digits long. Yeah. So we can access num0 through num6. There's always more than one way to count through something. We can use while loops. I like for loops. I'm going to do a for loop. For int I is equal to 0, I is less than the length of the array, num.length, I++. And print num I, or print line, whatever. And we know that these are all system.out.prints. I'm just lazy, saving time. That's one way. Another way is you can do this. I'm going to modify this a little bit though, so that it looks more like what I'm going to do next. I really wish I hadn't called it I. Please bear with me and allow me to change this. I'm going to call this C for counter. I was thinking I for index, but I changed. No, I'll go and leave it I. Sorry. Changed my mind. Okay. So we could copy the value into a temporary variable before we printed it out. Int n is equal to the number at position I. And then we could print out n. Do you have to do that? Absolutely no way. But I'm going to show you how the for each loop works, and it's pretty much exactly that. So that's a for loop. A for each loop looks like this. And the C# language actually uses the word each. However, C++ and Java do not. So for every int in the number array, print that out. So there we go. The syntax is a little bit shorter. It's easier to type for int variable name :num than to do all that rigmarole. This means that we don't have to index it. We already have a copy of the variable right there. N receives a copy of the value in each element in turn, just like this one did. This one copied the variable into n before printing it out. Here it's already filled in. So if you use a for each loop, you don't worry about indexing at all. You don't even have a counter. Why use a for each loop? Just two reasons, one smaller, one larger. The small reason is it's way easier to type. Syntax is a lot cleaner. The larger reason is that this syntax works with a lot of other things besides arrays. Works with a lot of abstract data types, queues and stacks and all sorts of things that you can't necessarily address with square braces. Now in the C++ language, you can use square braces on a lot of different data types because C++ supports something called operator overloading, where you could say, okay, I want my class to be accessible via a square brace system, even if it's not really an array. Java doesn't do that. So for each loop is cool because the syntax is cleaner and because it sets you up to use other data types. So let's write a little program that lets us enter some data into an array. File, new project, next, whatever. All right, just out of habit, I'm going to dictate the size of the array here. So I'm going to type final, which means constant in this language, final int array size, can I type, is equal to 10. This thing is going to have 10 elements in it. Why did I make it all caps? Because that is pretty much the industry standard for naming your constants. And this is a constant. What is a constant? A constant is a variable that cannot be changed during the execution of the program. You could always edit the program and change it, but like if I do this, if I decide that array size really ought to be 20, no, I defined it as a constant, so it can't be changed. Why is that useful? Well, if you set array size as 10 somewhere, you don't want another programmer to come along 2,000 lines lower in your code and then reset it to something else, and then your lines of code break. Okay, now let's declare the array. Are we going to enter names? Are we going to enter, I don't know. Let's do just an array of integers. That's kind of boring. Int, square brace. Let's give ourselves an array name. I'm not thinking of anything creative, so I'm going to call it IA for integer array, is equal to new int array size. Do we need the space there? No, we don't. If we print that out, right now it's 10 zeros. So for every int in IA, for every int space I in IA, with a colon, system.out.println I. Should be 10 zeros. And since I did print line, they're each going to be on their own line. Kind of tacky. There they go. There's another way that you can dump the value of an array to the screen, like this. This is pretty much just for debugging purposes, not the kind of thing that you would want to show a customer. But you use the arrays class. Arrays dot toString IA. The arrays class is a class that gives you helper functions for working with arrays, kind of like the wrapper classes, like double and integer, you know. This will turn an array into a string that we could then print. There we go. That looks nice, so I'm willing to stick with that. But it's awfully important to know how to step through our array for doing things like calculating the minimum, calculating the maximum, things like that. It's possible some of those functions are built into the arrays class. I'm curious about that, so I'm going to go over here and type in arrays dot. All right, what do we have? We have binary search, copy of, equals, fill, sort. We have some good stuff, but nothing that would calculate the sum of the array or the minimum or the maximum of the array. All right, let's get some data. We're going to need a scanner, of course. Scanner SC is equal to new scanner system.in. Add the reference, the import. As always, I say if you're using NetBeans and you click on the arrow and it says add import, that's a great choice. If it says create class, that's probably a profoundly wrong choice. Okay, let's do a loop. While loop, for loop, it doesn't matter. Let's use for. I'm going to use C for my counter. For int C is equal to 0, C is less than the length of the array. I could use array size, or I can just query the array for its length, ia.length. I'm going to do that. That's considered more proper programming. However, in some languages, such as C++, you don't have a .length function to query the array, in which case you would use your array size constant. Now let's print out a cute little message telling them what we want. Please enter array value plus C. So it'll say array value 0, array value 1, array value 2, and so on. Now we need to read that in. Int I is equal to, how are we going to get this in? SC dot next int will work. And let's copy it into the array. IAC is equal to I. I don't know if that's getting a little bit too terse or not. We could have called this num or value. I think I'd rather do that. I'm going to make it say int value is equal to, and then IA sub C is equal to value. I think that's a little bit clearer. Now let's print it out again. System.out.println arrays.toString IA. Here we go. Sorry, I tabbed. Okay. Please enter value 0. I'm going to do my favorite phone number. But then I have some digits left to do, so I'm just going to type in 1, 2, 3, until we're over with. And now I printed out the array.
Never
Okay, so the question came up is if you type in arrays dot and it flags it as an error, you're going to need the import statement, java.util.arrays. I do not recall whether I just clicked the red arrow and did that add, or whether this popped up here automatically or what. So let's write code that will calculate the sum and the average of that array. We're going to need another loop. I don't think it matters what kind of loop we use. This one had to be a for rather than a for each. And the reason why is if you recall this second version of the for loop we used that had a temporary variable. Oh, it's not even in that code, it's here. That one. Look what it's doing. It's copying the value out of the array, storing it in a temporary variable so we can manipulate it. And that's exactly what a for each loop does. In is a temporary variable that no longer has anything to do with the actual array, with that memory address 1000 or whatever it was. So you can change in and it doesn't change the original array. So for each loop is not a good loop to use with data entry. Use for loops. However, when you're retrieving values, it's totally cool to use a for each loop. So I guess we could write it either way, or we could pick one or the other. Let's use a for loop first, then we'll use a for each loop because that won't take much time to do. We're going to need something to hold our sum. I suggest a double. Why? Because what if you added so many ints that it got to be larger than an int? Well, yeah, we could have stored it in a long. But also when we calculate the average, it's nice to have it to be floating point. So double sum is equal to 0. Now we need our for loop again. Int c is equal to 0, c is less than ia.length, c++. I'm not going to even put braces because this is only one line of code. Sum plus equals ia sub c. And when I say sub, I mean the curly braces. And I put two equals symbols there like a junior programmer. That's wrong. One equal. Now, just because we feel like wasting the computer's time, let's also do the sum with a for each loop. Sum is equal to 0 for every int in IA. Add that to the sum. Sum equals, or sum plus equals I. And I made another mistake here. What did I do wrong there? That's the problem in the line. It would not give me the right answer. I'll give you a hint. If I type in the values 8675309, sum is going to equal 9 rather than 8 plus 7 plus 6 plus 5. Why?
There's no math going on.
There's no addition.
Yeah.
There we go. We need that. You may have already typed that just because you knew, but I didn't. Okay, so that's two ways of calculating the sum. They're actually pretty much identical, one shorter. Now let's calculate the average. How do you calculate the average? The average is the number, the sum divided by the number of elements. This could get you in trouble if you had an array of length 0. However, the number of times you'll have an array of length 0 is fairly rare. I say that, but this thing, this string args up here, is an array of length 0 almost all the time unless you're passing command line in. But anyways, ignoring the fact that you can have an array of length 0, double AVG, or average, is equal to the sum divided by the length of the array. Now let's print it out. System.out.println. Let's use printf because we're awesome. Sum is equal to %. Since these were all integers, the sum of them should be a whole number, so I'm going to make it %.0f, comma, average is equal to %f. I'm not going to limit the decimal points on the average. and then a/n. After our string, we're going to tack on comma, sum, comma, average. Might work. Let's give it a shot. One, 2, 3, 4, 99, 88, whatever. There we go. The sum is 412. The average would be that divided by 10 because there are 10 elements in the array. Okay, that's how you calculate the average, the sum of an array. Very important. Just commit that to memory. You got to be able to do that. And Bigor, it'll be on an exam. So, why is it so important? Because this is the same process you use for processing any list of data. You start at the beginning and you go until the end or until you hit some stopping criteria. So say we have this. Let's make a new array. Int NA for new array is equal to, and let's type some numbers in. Your numbers don't even have to match mine. 1, 2, 3, 5, 6, 987, 1, 4, 8, whatever. How would I find out what the maximum value of that array is?
NA.max. That work?
It would in a language that supported that.
Ah.
It's quite plausible that array lists support .max.
Mhm.
That's probably where you're remembering it. But arrays don't support methods.
Just doing that, yeah.
So what we got to do is we just got to count through it. We got to start at the beginning. So typically what I do is I create a temporary variable and I give the first value into that temporary variable. So, Lord, hold 1, 2, 3. Then we start counting. Is 56 larger than 1, 2, 3? Yay or nay?
No.
No. So you just keep on holding 1, 2, 3. Then we go to the next one. Is 987 larger than what you had?
Yeah.
All right. Here, take it. Okay. So now 987 is a value. Is 1 larger than that? No. Is 4 larger than that? No. Is 8 larger than that? No. So that's what we do. Is we assign
Okay.
into a temporary variable the first value of the array. Then we step through the rest, checking to find. Now there's two schools of thought on this, and I'll show you both of them. But let's do this. Int max is equal to the first element in the array. Now let's write a for loop, or a for each loop that'll step through the rest of them. If you write a for loop, you could start at this element and go all the way down. If you write a for each loop, you're going to start at this one. Does it hurt to start at that one? No. So I'm going to use a for each loop. For every n in the number array, if that number, if n is greater than the max, then max is equal to n. Then let's just print out max equals n. Wait, why did I do that? Max is equal to plus max. Write another loop that'll calculate the minimum. You ought to be able to do that on your own. It's only going to require an extraordinarily small amount of changes. You ought to be able to cut and paste it, change the word max to min, and then make one change to make it work. So I'm going to write it out long form. Int min is equal to what? The first element. And then for int n for every integer in the NA array. Now what's this if statement? If, I'm calculating min now, so what is my if statement going to be? Yeah, if n is less than the max, then max is equal to n. Then we can print out the minimum. So I'm just going to copy that print statement and change it to min.
Min's inside the if.
Yes, thank you. What in the world was I doing there? Okay. There. Nom nom. Okay. All right, this is going to get tedious because every time we run it, it's going to ask for those 10 numbers. But there it goes. It found the max as being 987 and the minimum equal to 1. This code could blow up if you have an array of length 0, and I'll show you what I mean. Go to this line here after the declaration and allocation of the array and change it to this. NA is equal to new int 0. It looks stupid, but it's totally valid. You can have an array with nothing in it. That's what you get when Java invokes your main if you haven't passed any command line arguments. This variable here has a length of 0. So when we run it, it's going to blow up with a red text error as soon as I enter my 10 numbers. Why? Because there is no element 1. So this line fails. So something that some people do is rather than initialize it with the first value, they initialize it with the the smallest possible integer. So here, instead of max is equal to NA sub 0, you could make this instead max is equal to integer with a capital I dot min value. Set it to the smallest possible value an integer can hold. And then you can do that again for the minimum one. Minimum is equal to integer dot max value. You start at the maximum value in the world, and then the first value will certainly be smaller than the max value, and so it will work properly as long as there's data. And if there's not data, then it still will not blow up, and you can validate whether it found anything or not by comparing it to max value or min value. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ew, and you still blew up. Oh. I didn't code out the references to the 0. Correct. So after my declaration of min, I just put a semicolon and 2 comments, or you can delete it. After my declaration of max, I put a semicolon and 2 slashes to comment it out. Now I enter my 10 numbers again. This is getting really tedious. I may change that to like a 2 or 1 rather than 10. But anyways. Okay. So the maximum is that absurd value. The minimum is that absurd value. And we would have to have our code check to see whether we got a valid value or not. And if the minimum equaled that, we would know that it was an array length of 0. However, you could just block off the whole code with an if statement. Something like this. If, you don't need to do this, but if na.length is greater than 0, then do all of our happy stuff. That's probably what I would do rather than using this max value and this min value. I prefer to set it to equal to the first value of the array. It makes the code look cleaner. Whichever. They both work. So I'm going to reinstitute what I had before. Delete the integer max value, or maybe I'll just comment it out. Comment out the min and max values. Put that assignment back in there, and then be happy. I have a problem here. Oh. Delete that if statement. So what can you store in arrays? You can store anything that you need in a list of names. An array can not only be a list of integers or doubles or floats or whatever, it can be a list of objects. A string is actually an object. And I'll show you what I mean. I'm getting really tired of typing in all that stuff about the max array, so I'm going to change my final int array size up at the very top to a 0. No, that's going to cause a problem when we calculate the average. I'm going to change it to a 1, so I only have to type in one value each time I run it. Now I want to declare an array of strings. String array, two braces, SA is equal to new, now let's call it names. Names, string array names is equal to new string, and I want 4 names in my array. Now let's print them out. For every string s colon in names, print that out, system.out.println s. You might think that it's going to print some blanks. Instead, it's going to print some nulls. Or it's going to blow up. I still haven't gotten rid of that. Okay. That NA is equal to new int 0. That was bad code. I'm getting rid of that. Okay, it printed out null, 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 null. And the reason for that is the array has space for 4 references to strings, but none of the strings have been created. We could prompt the user for the strings, and then we would have strings created, or we could, assign them to it. But until we do that, all it's got in it are no references. So when you are printing arrays out, and you might check to see if the strings are null and not print them out, or you have a counter that keeps track of how many valid pieces of data are in the array. That's called a partially filled array. Right now it's an empty array. It doesn't have any valid data. Let's make a little loop for filling that array. But let's let the user bail out early. So we need something that keeps track of how many items. Int items is equal to 0. That's how many elements we've put into it so far. And while items is less than names.length, we want data. We want to get some data in it. So system.out.println, enter a name, a first name. Then we need to read it in. String s is equal to sc dot next. Then we can store it into our array. Names sub items is equal to the string they just entered. But let's change this thing so it says enter a first name or none to quit. Before we assign that value, we need to check it. So after we do .next, let's put an if statement. If s dot equals quote done is equal to false. There we go. If we compare it to none and that's equal to false, we want to store that into the array, else we want to break. Now let's print the array out again. I'm just going to use arrays.toString. System.out.println arrays.toString and pass in the names array. So before we go into that loop, our names array is 4 nulls. Now I'm going to type in some names. Eric, Joe. Now I'm getting really bored, so I'm going to type none. Well, look at that. I made a mistake. It's overriding the first value every time. Look at my while loop and see if you can guess why it's overriding the first value every time.
It doesn't seem to do items.
Yeah, I never increment items. I could just do that there, or I could do it on its own line. I'm going to do it on its own line. Items plus plus. Joe, Eric, none. All right. So for any future processing of this array, we would want to use that items counter. Right now that items counter is equal to 2 because we've added to it twice. And all of our loops from now on could use that to only print out the valid values. And this will be the last thing we do to this code. Let's modify it. Or let's write a new for loop that uses that. For int c is equal to 0, c is less than items, C++, system.out.printf, %d equals %s \n, comma, let's print out our counter, and let's print out the name at that counter. So Joe, Eric, none. So when we use their code to print it out, we got our nulls, but our for loop successfully only processes data up to the point where there is valid data. This is what's known as a partially filled array. We did enter some data. The user quit early. The array isn't filled all the way out, so we need to have some way of knowing where to stop. And where to stop is not the end of the array. It's up to the number of items stored in it. Alrighty, that's about enough. Let's look, see. Start the recorder. So here's the homework for one-dimensional arrays. Here's what it needs to do. Ask the user for how many numbers they want, like 10. Use the value to allocate that many. I don't care if you use ints or doubles, up to you. Use a loop to let the user enter that many numbers. Display that array. And then calculate and display the sum, average, min, and max of the array. And we already did most of that in the in-class assignment. In fact, we pretty much have done almost all of it. But don't just copy and paste, rewrite it from memory or by looking at this. All right, does that make sense, y'all?
Yes.
Okay.
Oh, that's what I was.
Now comes that frightening moment where I hit the stop button and we find out if it crashes or not.